For question 20, we're looking at number 92 out of your book, section 1.4. And we're asked to describe the area of this rectangle in terms of x, as well as graphically determine the domain of that area function. So you can see here we have a half circle, which is represented by the function root 36 minus x squared, and we have some rectangle in there, and we don't know what the dimensions of the rectangle are. So first let's figure out an expression for the area of this rectangle. Well, if this point is x comma y, that means that this value right here must be x, and this value right here must be y, because that's the coordinates of that point. So you can see, since this is a symmetric rectangle, if this distance from 0 to x is here, then you must have the exact same distance from 0 to x on the left, meaning the entire base of this rectangle is going to be 2x. The area of a rectangle is, of course, base times height. So now all we need to do is figure out the height. But the height here is clearly just y because we're going up from 0 to y. So the height of the rectangle is y. So we get that our area is 2xy. Now that is not a function of x, so we need to make it a function of x, meaning we need to do something with the y. Thankfully we can, because we know that y is equal to square root of 36 minus x squared. So we can just substitute that entire expression for y, and then we'll only have x's, which is exactly what we wanted, which would give us that our area is 2x, and now instead of y, we write that root 36 minus x squared. And that is the area of that rectangle for any given x. So the other thing that we were asked to do is graphically determine the domain of this function. Well, let's see what would make sense for x here. By the way, these points that touch the edge are at 6 and negative 6. So you can see here, as you moved x over, if x was getting closer and closer to 6, this rectangle would be getting smaller height-wise, but longer in the width. And eventually, if you made it all the way at 6, you wouldn't even have a rectangle anymore. You just have a line, because there wouldn't be any height. So you can see here that 6 is the maximum that we could go to. Also, it wouldn't make sense to go past 0, because then we're just going to have our area be negative. Think about this function here. If x is 0, meaning we're right here, we don't have a rectangle either. We would just have a line like that, and that would be our minimum that x could be. So your domain of this function only could go from 0 to 6. Those are the only possible values that you could have for x in this picture that would make any sense, and that's the domain of this function.